We are talking about analogy of normals, means how why we calculate normals and how we calculate normal in 3D graphics OpenGL. So normal always comes as a kind of matter or matrix of confusion, and why we want normal and how it is different to rest of the things, kind of in, I would say, vectors. Okay, so there are two things in OpenGL. One is surface, means one is model. Model has vertices, and other is normal. So model is nothing but it's a surface, like, but in kind of in digital world, there is nothing analogous. There is nothing kind of that is continuous. So means in analog way. Uh, so there is no continuous surface. So it's a set of surfaces like triangles. So many triangles, they constitute a surface. So surface is nothing but it's a kind of a plane which has minimal three vertices. So if I have a three vertices, if I connect it, then minimum I can make a triangle and it has a surface. Okay. So surface has three vertices, and each vertices I can say that two vectors they meet at vertex. So that is the vertex. But what about normal? Normal is not a surface. Normal is the direction. What is the surface and what is the direction? If normal is the direction and surface is a kind of, it has a direction and position. So we now we have three main transformations, like translation, and we have rotation, and then we have scale. So if I talk about surface, it constitutes everything. But if I talk about a normal, it's a vector. Vector means it has a direction, okay, and it has a position. It doesn't have any position. A surface has a position. Surface can be scaled, and surface can be transformed in translation. Surface can be rotated. A normal is a direction. If it is a direction, neither it can be scaled nor it can be translated. It can only be rotated. Okay? So that is the big difference between a surface and a normal. So whatever the lighting calculation we have seen, we do in normals. I mean, we do in directions. We don't do in surfaces. So if I am doing lighting calculation to the surface, somehow we try to get the directions. That we kind of cross. Okay. Now, what is the analogy of what is the relationship, I would say, between the surface and the normal? Okay. So normal is, if I believe that surface, okay, surface is nothing but it's a plane. Surface can be 3D, like I have a sphere, okay, and a sphere is 3 dimensional. It's not 2 dimensional. If I try to get a plane at any point on the surface, if I have a sphere, at any point on the sphere, I say that this is the surface at this point. But this is physically possible in OpenGL because there is no kind of analog things. So things are discrete. So everywhere there are triangles, okay, or quad or whatsoever. But it is not analogous. So in that way, if I have a surface, okay, I am talking about analytical surfaces. So two kind of surfaces are there. One is analytical surfaces, means continuous surfaces. That is based upon analytical equation. X square plus y square plus z square equal to radius square. So that is the equation of a sphere. Okay, so x square plus y square plus. So this is analogous. We call it analytical surface. So it is based upon some equation. And there is another kind of like polygon data. Okay, so we have many polygons. The way we are talking in OpenGL. So we have kind of triangles. So now if I have a kind of surface, so if I have a surface and I am trying to find normal at any point, so my surface is 3D surface and I am trying to find normal at any point, then can I find a 2D surface? So at any point, can I say that at this point, this surface makes sense? I have a 3D surface. On the surface, there is any point. At that point, I place a 2D surface. And I say, this is the surface that belongs to this point. If I know the surface, then I can get the normal vector from the surface. So a surface is nothing but, as I said, a surface is nothing but, if it is a 2D, then two vectors would make the surface. Like if I have an xy surface, xy surface means one line in x direction, one line in y direction. If I think about it, then it becomes a surface. But behind the surface, there is only two lines. So if I am able to find two lines, then I can think about a surface. Okay? Or, anyway, if you have surface, then there is a two line behind the scene. Now, if I have two lines, then there is a surface, this line, surface, and then normal. Okay, so the two lines need to be. Now, I have to find kind of cross product. So if I cross these two lines, then I know the normal. So we are talking about how to calculate normal. If I have analytical surface, a surface through formula, or I have polygon data, set of triangles, set of chords, how I can find the normal? So if I have analytical surface, then at any point I would try to find the kind of tangent. If I have a sphere, at any point I have to find the tangent in two directions, x direction, y direction. If I find the tangent in two directions, then surface is ready. If surface is ready, then two directions cross and we find the norm. So that is the way we calculate the norm. There are two ways again in the analysis. So we are talking about analytical surface. So in analytical surfaces, we find that at any point, any vertex, we try to find the surface, and from that surface we find the norm. Okay, there is explicit way that analytical surface is mentioned. Okay, that we will see, and then the implicit way like x square, y square, z square. So that if I have my explicit way is very difficult, because if I have explicit way, I'll try to find derivative so that I can get the tangent, and if I get two tangents in two directions, surface is made and then normal. Or if I am getting the implicit way, okay, then means I am not getting one surface and normal. Then I can think about gradient. So if I get the gradient, like if I have three coordinate surfaces, then all three gradient, if I get a derivative at that point or derivative equation, then also we can find the normal. That means now in the polygon data, how we find the normal? I think implicitly we have done. So if I have a polygon data, then already if polygon data is a triangle, then already I have a surface. Everywhere surface is different. Okay, so many triangles are there. One triangle, okay, in one triangle the normal would be seen all the vertices. So doing cross of any two lines and I can find the normal. Or in the particular region, okay, we can do averaging or some kind of intelligence. Depends upon the surface. If surface is like this, then this and this, we can just two normals we can average. If surface is like this, okay, then we cannot do averaging. So those conditions that will then the most awaited, okay, that is the transformation. So that later in the discussion we'll see that first we'll see that if I have a static surface, then how I can find the normal. Normal is not a surface. I cannot imagine that normal is a perpendicular surface on the surface. Normal is a pure direction. Direction has no surface. Direction can have magnitude and direction is direction. So one vector can have a magnitude and it can have a direction. So you can refer to kind of a vector tutorial on the vectors. So first we'll calculate the static normals from the surface and then we'll see the transformation. So that will